California is in its fourth year of record drought, resulting in high tree mortality rates and increased pest problems from both native and exotic insects and diseases. The Monterey Pine Forest in Cambria and San Luis Obispo County is just one example of a California forest suffering from 4 years of drought, overstocking, and pest problems. The pests in this case are the native Ips engraver beetle and the introduced pine pitch canker disease. The Cambria Forest is a unique site, one of just 3 native Monterey pine forest stands in California. Local foresters are estimating that up to 85% of the pines in the Cambria Forest are dead or dying from the combination of drought and pests. Unfortunately, the Cambria Forest is not unique in suffering from drought and pest-related mortality. This is an area of the southern Sierra Nevada in 2009 taken from Google Earth. And this is that same area in 2014 after suffering severe drought and pest-related mortality. Extremely low reservoir and lake levels are typical signs of what's occurring due to the drought in forested hillsides. Forest soil moisture is also extremely low, resulting in less water available for plants and trees, severely weakening the vegetation. 2014 had the lowest rainfall level since records began in California. Now, 2015 is shaping up to be an even worse year. At present, there is no end in sight for the California drought. Drought conditions exist statewide, with the worst conditions in the coastal south. Even the relatively wet north coast is also experiencing drought this year. Forest health conditions in California are made worse by changes in stand structures and species that have occurred since European Americans arrived in the state. Stands are significantly more dense than in the past, leaving trees in greater competition with one another for sunlight, nutrients, growing space, and available soil moisture. Stressors on forest health are more severe in dense stands than the more open stands that historically existed. Moisture stress that often accompanies prolonged drought often lead to outbreaks of bark beetles. These insect pests reproduce with multiple generations per year and normally only attack trees that are under some form of stress, like water shortage, major storm damage to the tree, wildfire damage, or other more subtle causes like airborne pathogens. During prolonged droughts, however, all trees are under stress and can be attacked, including otherwise healthy-looking trees. Presently, the southern Sierra Nevada region is in an epidemic of pine bark beetles, with estimates of at least 20 to 25% of the pine trees being killed in some of the counties. Other conifer pests, which would normally only attack a few scattered, weakened individual trees, during prolonged periods of drought will also start killing great numbers of trees over wide areas. Conifers that normally fight off attack by bark and engraver beetles by pitching them out do not have the moisture reserves to do so. Beetles will rapidly spread to otherwise healthy trees during these prolonged dry periods. And it's not just the southern Sierra Nevada that's experiencing drought-related pest mortality. All parts of California are experiencing similar problems. As some people are calling for extensions of the formerly designated zones of infestation for bark beetles, it's becoming evident that such a zone may soon need to include the majority of all forested parts of California. Pitch tubes are the tree's natural defense mechanism against bark beetles, but cannot be formed during periods of extreme moisture stress. Consequently, the first indication that the tree has been attacked by bark beetles is the sudden turning of the needles from green to red or even brown. It's very typical for bark beetle populations to explode and reach epidemic levels during drought periods like this one, usually slightly delayed though from when the drought starts as the trees become more increasingly stressed. The trees will remain under stress for a few years after the drought breaks, resulting in a continuation of the bark beetle epidemic. Historically, bark beetle outbreaks can last from 3 to 5 years after a drought ends. Timing of rainfall is also important to bark beetle outbreaks. Late spring and early summer rains will help trees fight off attack more than midwinter precipitation when trees are dormant and bark beetle activity is reduced. However, little or no rainfall of any sort will result in significant bark beetle outbreaks throughout the year. Now, trees under stress from other pests such as exotic insect gold-spotted oak borer or the exotic disease sudden oak death are more likely to die during periods of drought. The combination of the stress agents is often what will ultimately kill the trees. Another issue with the drought is that younger trees with small root systems often die first. This is a significant loss since these younger seedlings are needed to replace the older trees killed by the drought and insect and disease problems. Unfortunately, today many of the young seedlings and young saplings are dying throughout the state. If natural regeneration is succumbing to severe moisture stress, the survival of recently planted seedlings is also questionable. Drought conditions often cause many hardwood trees, particularly oaks, to lose their leaves prematurely during their normal growing period. With no leaves, trees are unable to produce the food necessary for future growth and become predisposed to attack from a suite of other damaging insects and disease. Many hardwoods are especially susceptible to drought-related mortality since they tend to be growing in drier, lower elevations of the state, that compared to conifer species, which are in higher elevations where we get more moisture. Also, many are often reliant on streams and spring waters that dry up during periods of drought. Such trees that are conditioned to be dependent on regular sources of water are particularly vulnerable when the water dries up. Trees killed during drought often become a fire hazard and may contribute to excessively high forest fuel loads. Trees killed by drought and bark beetles are extremely dry and easily burn during wildfires and help spread fire to surrounding living trees. Such extensive dead and dying trees will create fire fuel hazards over large areas of California and may lead to future large and damaging wildfires. In just the past decade, California has seen some of the largest and most damaging wildfires in its history. The potential for even more catastrophic fires may loom on. Now, fuel loads may seem even higher than most people expect. The large areas of dead and dying trees are often out of view of most people, but will still affect wildfire activity and behavior. Not only are trees dying, but so are many of the understory shrub species, which increase fuel loads and carry wildfires over large areas. Dead understory shrubs, small trees, and other vegetation can act as a ladder for means of spreading the fire from the ground level up to the treetops from tree to tree, allowing that wildfire to grow in size. Such mortality can increase the size and severity of fires, endangering firefighters, residents, and communities, especially in the wildland-urban interface, which all impacts our air quality and our water quality. Drought-related mortality is also dangerous to homeowners, resulting in dead trees that can be hazardous to structures, vehicles, and even to human life. Dead trees can be difficult and very costly to remove for homeowners. Trees near homes often require expertise to be removed without causing further damage to structures. So drought and pest-related mortality can create hazards to power lines, roadways, and impact community emergency escape routes and even firefighting equipment access to communities in danger from wildfires. With more dead trees from drought and pest-related mortality, that only decreases a homeowner's defensible space around their home and other buildings. Now, trees and other plants in the forest help clean the air, as well as absorb huge quantities of carbon dioxide, one of the more prominent greenhouse gases attributed with climate change. In steeper mountainous terrain, tree canopies intercept large raindrops, softening the rain impact on the ground, while intertwined tree root systems help anchor the forest soils to prevent soil erosion. When large areas of forest are destroyed from disease, insect, or wildfire, none of these important functions are maintained, often resulting in extreme erosion, which sends huge volumes of soil and debris into our streams, choking off critical fish habitat and contaminating our precious water supplies. Since the majority of California's limited water supply comes from the upper mountainous watersheds, it's important that aggressive steps be taken to help mitigate negative impacts affecting forest and watershed health. The growth of forests is considered to be a major source of carbon sequestration, helping to fight climate change, but this is true under healthy forested settings. Drought-related mortality can turn a carbon store into a carbon source. Dying or dead trees will no longer be able to sequester carbon. Instead, these trees will begin to release carbon back into the environment as they rot and decay or burn up in fires. There is growing concern that without serious intervention, California forests may become an emission source of greenhouse gas. For this reason, CAL FIRE strongly supports active management of our forests, where improved forest health is a primary goal, and our forests are much better able to cope with climate change, urban pressures, and even low-intensity wildfire. To give a drastic image of the extent of the drought and pest-related mortality issues here in California, here's a return to the Google Earth image of the central Sierra Nevada region from May 24, 2009. And this is the exact same area from the beginning of the drought-related bark beetle outbreak taken in May 26, 2014. The area is located near the historically large rimfire, and there are too many forested landscapes similar to this one for us not to pay attention and for us not to be concerned. Finally, a return to the Cambria forest. Just one forest in California now experiencing a significant mortality event from drought and pest activities. Present estimates of dead and dying pines in the forest are over 3/4 of the total. This is one of the most extreme examples, but high drought and pest-related mortality conditions can now be found throughout the state of California. It may be too late to save many of the trees in Cambria, but it's not too late to improve our management practices on federal, state, and private forest lands.